Next up, we have inequalities. So how do we express the inequalities of terms? So we have 5 symbols. Number 1, this is the, or let's say, not equal to. Number 2, we have less than. Number 3, this is less than or equal to. Then number 4, we have the greater than. Number 5, this is the greater than or equal to. So these are the 5 symbols. How do we express inequalities of terms? So since we have inequalities, we have several values that will satisfy the inequalities. So we place them in one set. Then this set is called the same. We have the solution set. So how to determine the solution set of a given inequality? So we are to perform some of the basic operation. So first one we have, let's say this is if we are to do addition or subtraction. Okay, so if you are to do subtraction or addition or subtraction of inequalities, so if we are looking for, or if we are solving for the solution set of an inequality, okay, if we are to perform addition or subtraction, the sense of inequality is not changed. So example, let's say this is x minus 3 is greater than 2. So for example, we are looking for the solution set of this inequality. So if we are to add or subtract the same number on both sides of the equation, the sense of inequality is not changed. So for example, how do we compute for the solution set? This is x minus 3. So we are adding 3 on both sides of the inequality. So this is 2 plus 3. Just to eliminate 3. So the same sense as we transpose. We have now x is greater than 5. So how do we express the solution set of an inequality? So we have the first one. We can express it by an interval notation. So by interval notation, the solution set of this inequality, that is, x is greater than 5. So we have, since if we have this symbol, the greater than or the less than, we are to use open parentheses, starting with x is greater than 5, that is 5 up to any value greater than 5 up to infinity. So that is how we express the solution set by using interval notation. The other way to present the solution set, we may use the number line. Okay, so we have, for the number line, again, our solution set is x is greater than 5. So we have to place an open circle on 5, then draw an arrow to the right, that is towards the positive infinity. So, an open circle represents that 5 is not included in the solution set. Okay? So example, if we are to satisfy this inequality, what if x minus 3 is greater than 2? So we say that 5 is not included. We are placing an open circle, that is 5 minus 3 is greater than 2. This is 2 greater than 2 is not true. Alright, so it means 5 is not included. So we are using any value that should be greater than 5. So 5.1, 5.2 up to positive infinity. So again, these are the two ways how to present the solution set of an inequality: interval notation and the number line. So again, also, if we are doing addition and subtraction, if we are to add or subtract same number on both sides of the inequality, the sense of inequality is not changed. Okay, so let's have another example. So for example, we have the inequality that is 3x plus 2 is less than or equal to 2x minus 2. So we have, how do we solve for the solution set? So we may have this one, 3x plus 2. So we are to subtract 2 on both sides. Okay, less than or equal to 2x minus 2 minus 2. So again, if you are subtract the same number on both sides of the inequality, okay, the sense of inequality is not changed. So we'll be having this now 3x is less than or equal to 2x minus 4. So next is 3x. Let's say we are to eliminate 2x. So subtracting 2x on both sides of the inequality. I just eliminate this term. So we have 3x minus 2x is x is less than, this time is less than negative 4. So this is our solution set. So again, how do we present the solution set of an inequality? So first one, by interval notation. So interval notation, so this time as you can see we have the less than or equal to, or if it is the same as if we have the greater than or equal to. So this is any value less than negative 4. So which means this is towards the negative infinity. Alright? So we have x is less than or equal to the negative 4, which means we are towards the negative infinity up to negative 4. So this is up to negative 4. If we have the equal to sign, which means this number is included. So negative 4 is included or part of the solution. So this is by interval notation. So again, how do we present the solution by the number line? So let's say this is on the point of negative 4. So our solution set is from the negative infinity up to negative 4. So we are to draw a shaded circle or closed circle above 4. That represents that negative 4 is included in that solution. Then draw an arrow towards the left or towards the negative infinity. So this is our solution set. From negative infinity to negative 4. Shaded circle, which means negative 4 is included. So if you are to justify the inequality, this is 3x plus 2. This is less than or equal to 2x minus 2. So let's say x is equal to negative 4. So this is 3 times negative 4 plus 2. Is it less than or equal to 2 times negative 4 minus 2. This is negative 12 plus 2 is less than or equal to negative 8 minus 2. So this is negative 10 is less than or equal to negative 8 minus 2 is also negative 10. So the inequality is justified. That is, negative 10 is also equal to negative 10. Alright, so this is our second example. So again, so for the operation of the determination of the solution set of inequalities. So for multiplication and division, the only time that you are to reverse the signs of inequality is that if you are to multiply or divide both sides of the inequality by a negative number. So example, for example, we have this inequality, let's say 2 over 5 of x. 5 minus 10 is greater than 4 over 5. So for example, we are required to determine the solution set for this inequality. So multiplying both sides of the inequality by 5 to eliminate the denominator. So as you can see, we are multiplying positive numbers, so which means the sense of inequality is not changed. So this is the same as 2x minus 50 is now greater than 4. So we have this is 2x minus 50 plus 50. So we are adding a same number on both sides of the inequality. Is greater than 4 plus of 50. Just to get rid of these terms, so we have now 2x is greater than 54. So to compute for the value of x, we divide both sides of the inequality by 2. So again, we are dividing both sides of the equation by a positive number. So okay, the sense of inequality will not change. So we have this is x is greater than 20. Okay, x greater than 27. So this is our solution set in terms of an inequality. So how do we express our solution set as or in interval notation? That is x greater than 27. So we are using parentheses. This is 27 up to positive infinity. So again, the solution set in number line, let's say it says 0, this is towards the negative infinity, and the positive infinity, then we have that 27. Okay, so since 27 is not included, there is an open circle towards the positive infinity. So this is our solution as an inequality, interval notation on the number line. So let's have another example. So for example, we are required to solve for the solution set of this inequality. We have 28 over 3 minus x over 2 is greater than or equal to 10 over 3. So we may simplify this inequality by first removing the denominators. So we may multiply both sides of the inequality by 2 and 3. So we are multiplying positive numbers. So therefore, we are to maintain the sense of the inequality. So it's the same as 28 times 2 over 2, 3, 6. So we may cancel 3. We have 28 times 2 is 50. This is 56. Negative x over 2 times 2 times 3. We may cancel 2. So this is minus 3x. Is greater than or equal to, we are to maintain the sense of inequality since both are positive. We may cancel 3, 10 times 2, this is 20. So we have, this is 56 minus 3x is greater than or equal to 20 minus 56. We are subtracting 56 from both sides of the inequality. So this is now the same as negative 3x. 20 minus 56 is negative 36. So divided by negative 3. At this time we are dividing both sides of the inequality by a negative number. So since we are dividing it by a negative number, so we are to change the sense of inequality. We are to reverse. So this is now x. So this time it should be less than or equal to positive 12. So this is our solution set in terms of an inequality. So how do we present that in interval notation? So this is towards x is less than, so this is towards the negative infinity up to positive 12, and 12 is included, so we are using bracket. Since this is less than or equal to. Then for the number line, so our solution set is from negative infinity to positive 12, and 12 is included. We are drawing a close circle and draw an arrow towards the negative infinity. So this is our solution set. Inequality, x is less than or equal to 12. Interval notation from negative infinity to positive 12. Then we have the number line from negative infinity to positive 12, and 12 is included. So our next example, how to deal with quadratic inequalities. For example, we have this inequality, x squared minus 6x plus 8 is greater than or equal to 0. First, we are to factor. Let's say this is x. So what are the factors of 8 that will give us a negative 6, or the sum of a negative 6? So obviously, I think both are negative. So this is negative 2 and negative 4. So negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. Should be greater than or equal to 0. So take note, we are looking for values that are greater than or equal to 0. And reminder that positive values, positive numbers are greater than, let's say positive values are greater than 0. So we are looking for we are looking for a positive value from the first quantity and another positive value on the second quantity that will give us a positive product. Okay? So positive times positive is also positive, or the other way around, negative from the first quantity, a negative value from the second quantity is also a positive value. So we are avoiding the value with negative on one side or the other side and positive on the second one. That will give us a negative product. So we are looking for these values that positive, positive, negative, negative. Since positive values are greater than 0. So if we are to observe what will be our reference values from x minus 2, if we are to just get the equivalent of x as our reference values. X minus 2 is equal to 0, so x is equal to 2. One reference point, x minus 4 is equal to 0, and x is equal to positive 4. So let this be these 2 points be our reference points. On the number line, so our reference points are 2 and 4. So let's have 3 intervals. Our first interval is from negative infinity to positive 2. Second, from positive 2 to positive 4. And last, we have from positive 4 to positive infinity. So take note, we are looking for the product of a positive value since positive values are greater than 0. So we are just to assume a value. This is from negative infinity to positive 2. What are the values that can we use to have this product? So let's say let x is equal to, I'll be using positive 1 since that is within the interval of negative infinity to positive 2. Okay, let x is equal to positive 1. So we have, this is 1 minus 2 multiplied by 1 minus 4. Is this a positive value or negative? So this is negative 1 multiplied by negative 3. It will result to a positive product. So this is positive. Okay, let's have the interval from 2 to 4. So let's say I'll be using positive 3. So let's say let x is equal to 3. So this is the same as 3 minus 2 multiplied by 3 minus 4. So we have 3 minus 2 is positive 1, 3 minus 4 is negative 1. That gives us the product a negative value. So this interval will give negative values. And then for the last interval, let's say we are using let x is equal to 5. That is the same as 5 minus 2. This is 5 minus 2 multiplied by 5 minus 4. 5 minus 2 is positive 3. 5 minus 4 is positive 1. That will give us a positive product. This is also positive. I take note that we are looking for product of these 2 quantities that will give positive product. So the intervals that satisfy this inequality, we have the intervals. This will be our solution sets. So our solution sets we have that is from negative infinity. This is from negative infinity using first using inequality. that is x, okay, take note, we are using equal to sign, is less than or equal to, okay, positive 2, then, okay, this is negative, we ignore this portion, we are considering this from 4 to positive infinity. So that is x is greater than positive 4. So this is, we are using OR since that is the union of two sets. From negative infinity to 2 or from 4 to positive infinity. In terms of inequality, that is x is less than or equal to 2 or x is greater than or equal to 4. In terms of interval notation, this is from negative infinity up to positive 2. Take note that 2 is included in our solution set. Then, or it means union. That is from positive 4 up to positive infinity. And 4 is included. If the value is included, we are using bracket. Okay, that is our solution set as inequality and interval notation. In terms of the number line, we are using a shaded circle or closed circle. This is towards the negative infinity. That is from negative infinity to 2, and this is from 4 towards the positive infinity. So this will be our solution set. Okay, so let's have another example. So for example, we are to determine the solution set of the inequality x squared plus 3x minus 4 is less than 0. So we have, let's have the factors. We have x, okay, x. So what is the factors of negative 4 that will give us positive 3? These values are negative 1, okay, negative 1 and x plus positive 4. Okay. Is less than equal less than 0. So we have x squared by 4x minus x then negative 4. So we are looking for values that are less than 0. So when do we have a value that is less than 0? So take note that negative values or negative numbers are less than 0. So therefore we have from these two quantities again, what to have a negative value, you should have a product of negative and positive. So we are avoiding the case of positive multiplied by positive or negative multiplied by negative, since the product of these two will result to positive. We are just looking for this case, okay, having a negative product from these two quantities. So our reference points, that is, we have x minus 1 equal to 0, x is equal to positive 1. Then the other is x plus 4 is equal to 0, and this is x is equal to negative 4. So let these 2 points be our reference points. On our number line, so we'll be having again 3 intervals. The first interval is from negative infinity up to negative 4. Then next one is from negative 4 to positive 1. And last is from positive 1 to positive infinity. So first, let's have let x, let's have a value from negative infinity to negative 4. So for example, I'll be using x is equal to negative 5. So you have here, this is negative 5 minus 1. This is negative 5 minus 1 multiplied by negative 5 plus 4. So obviously, this is negative multiplied by negative. So this is negative multiplied by negative. Will give us a positive product. So the interval from negative infinity to negative 4 is positive. And the next, from negative 4 to positive 1, let us consider one value in between. Let's say this is Okay, I'll be using negative 3. So let's say let x is equal to negative 3. So this is negative 3 minus 1 divided by negative 3 plus 4. So negative 3 minus 1 is a negative value. Negative 3 plus 4 is a positive value that will give us a negative product. Okay? The product of this interval will be negative. Alright, then next, for example, I'll be using, let x equal to positive 2. A value in between positive 1 to positive infinity. So from this equation, this is the same as 2 minus 1 multiplied by 2 plus 4. So 2 minus 1 is positive 1, 2 plus 4 is positive 6. That will give us a positive product. This is also positive. Take note that we are looking for, or we are satisfying this inequality. The left side should be less than 0. And negative values are less than 0. So among these intervals, which interval satisfy the inequality? Which interval satisfies the inequality? That is from negative 4 to 1. Okay, so our solution set in terms of inequality, that is from negative 4 to 1. So take note, this is less than. That is from negative 4 is less than x less than positive 1. Okay, so negative 4 and positive 1 are not included in that solution. So in terms of interval notation, this is from negative 4. We are using parentheses, negative 4 up to positive 1. Negative 4 and 1 are not included. And our number line, since negative 4 and 1 are not included, we have to draw open circles, then connect the line. So that will be our solution set. In terms of inequality, set the notation, interval notation, and the number line.